Pressure is force divided by area. But in thermodynamics, we can measure two types of pressure, absolute pressure and gauge pressure. Absolute pressure is the pressure measured from absolute zero, that is from perfect vacuum. It's the pressure we normally talk about. Gauge pressure is the difference between the pressure of the surroundings and the pressure of our system. Since the surroundings is usually the atmosphere, this refers to the atmospheric pressure. So gauge pressure is the difference between absolute pressure of the system and the atmospheric pressure. If the absolute pressure is more than atmospheric pressure, we simply call it gauge pressure. If it's less than the atmospheric pressure, we call it vacuum gauge pressure. We do this so that we can always write pressure as a positive number. These different types of pressure are the result of the devices we use to measure pressure. These devices have some limitations for their use, and that's why we had to invent new types of pressure. Just like the two types of pressure, there are two types of devices used to measure pressure: barometers and manometers. A barometer measures absolute pressure. But due to the limitations in its design, we can only use it for a limited range of pressures. So for this reason, they are only used to measure atmospheric pressure. We know that as we go to hilly areas or climb mountains, it becomes difficult to breathe. This is because of the reduced atmospheric pressure there. Barometers are the perfect device to measure atmospheric pressure. But in lab conditions, we have a large range of pressures. For this, we invented a new device called the manometer. These measure the difference in pressure between two bodies. We usually use manometers to measure the difference of pressure between a system and the surroundings. That is, the difference in pressure of a system compared to the atmosphere. In other words, manometers measure the gauge pressure. By using both these devices together, we can find out the absolute pressure of a system using the equation: absolute pressure is equal to the atmospheric pressure plus the gauge pressure, or minus the vacuum gauge pressure. So, the absolute pressure is equal to the barometer reading plus or minus the manometer reading. These devices are made of mercury, so we can't measure the pressure directly in Pascal or bar. Instead, we measure the height of the mercury in the device and convert this into Pascal using the formula P is equal to rho mercury into GH, where rho mercury is the density of mercury, G is the acceleration due gravity, and H is the height of the mercury column, which is the barometer or manometer reading. The thing we need to remember here is the density of mercury, rho, which is 13595 kg per meter cube. If we know this, we can convert the reading of a barometer or manometer, which is in millimeters of mercury, into Pascal. For example, if the barometer shows a reading of 760 millimeters of Hg, we can convert this into pascals, using the equation, P is equal to 13595, into 9.81, into 760 millimeters, or 0.76 meters. Which gives us a value of 101,358 pascals, or 1.01358 bar. The standard value of atmospheric pressure is 1.01325 bar, or approximately 1 bar.